Okay, we will continue now with problem number 4, another break-even problem. In this problem, manufacturer has a monthly fixed cost of $30,000 and a production cost of $9 per unit. He will sell his product for $15 per unit. Let's write the cost and the revenue function for each of these. The cost function is 9x plus 30,000, which is the variable cost plus the fixed cost, and the revenue function is equal to 15x. Write the company's profit or loss if they sell 2,000 units. First, let's develop the profit equation by subtracting the cost function from the revenue function, that is r of x minus c of x. That gives us 15x minus the quantity 9x plus 30,000, which is equal to 6x minus 30,000, the profit function. So P of 2,000, which is function notation for calculating the profit for 2,000 units, is equal to 6 times 2,000 minus 30,000, which is equal to negative $18,000, which, by the way, is a loss of $18,000. Problem 5. A firm is considering two capacity alternatives, A and B. Alternative A would have an annual fixed cost of $110,000 and a variable cost of $25 per unit. Alternative B would have annual fixed costs of $120,000 and variable cost of $20 per unit. The selling price per unit is $50. Which alternative has the lowest break-even point? In order to solve this problem, we must consider both profit functions for alternative A and for alternative B. Alternative A gives us a profit function of 25x minus 110,000, and B gives us 30x minus 120,000. Setting each of them equal to 0 will give us each of the break-even points. For alternative A, 4,400 units, and for alternative B, 4,000 units. 4,000 units is obviously the lowest break-even point, so alternative B would be our choice here. Question B. Which alternative will produce the highest profits for an annual output of 25,000 units? Once again, we will consider both alternatives, profit of A and profit of B, for x equals 25,000 units. Substituting and calculating, we get a profit for alternative A of $515,000 and a profit for alternative B of $630,000, which will give us our highest profit. Use the following information in order to answer the questions. Given a fixed cost of $20,000 and a variable cost of $250 per unit and a revenue of $5 per unit, what is the break-even quantity produced and sold? Solution. Break-even point of 2.5x minus 20,000 equals 0 yields a solution of 8,000 units. And what are the total revenues for the break-even quantity? So R of 8,000 is equal to 5 times 8,000, which is a revenue of $40,000. Next question, what quantity would be required for a profit of $35,000? In this case here, we will set the profit function, 2.5x minus 20,000, equal to a profit of $35,000. Solving this, we get x is equal to 22,000 units. Part D, what profit or loss would there be for a quantity of 20,000 units? This is a substitution of 20,000 units into our profit function, 2.5x minus 20,000, so P of 20,000 is equal to $30,000.